Hi everyone, welcome to my YouTube channel Maths Academy by Sudhir, and I am Sudhir Desai. In this video lecture we are going to study matrix method for finding the solution of simultaneous equations in three unknowns. So let's see what is the formula. So consider simultaneous equations with three unknowns as a1x plus b1y plus c1z is equals to d1, a2x plus b2y plus c2z is equals to d2, and a3x plus b3y plus c3z is equals to d3. So we have to solve these equations using matrix method, or it is also known as a matrix inversion method. The formula is x is equals to a inverse into B, where x is equals to matrix of unknowns. What are the unknowns? The terms which we have to find the value. So they are x, y, z. Next is matrix A. It is matrix of coefficients. So we have to write the coefficients of x, y and z from equation 1, 2 and 3. So in row 1 we will write down the coefficients of x, y, z of equation 1, which are the a1, b1, c1. In row 2 we are going to write coefficients of x, y, z from equation 2. They are a2, b2, c2. And in row 3 we will write coefficients of x, y, z of equation 3, a3, b3, c3. And matrix B is known as a matrix of constants on right hand side of the equation. They are d1, d2, d3. So formula for finding the solution of simultaneous equations using matrix method is x is equals to A inverse into B. So here important factor is to find A inverse. So let's see what are the steps to solve simultaneous equations using matrix method. So step 1, write the formula for matrix method, which is x is equals to A inverse into B. Next steps are for finding the A inverse. So for finding A inverse, next step is find determinant of matrix A. Step 3, find cofactor matrix of A. Step 4, find adjoint of matrix A. By using the formula cofactor matrix of A, its transpose. Step 5, find A inverse using the formula 1 upon determinant of A into adjoint of A. And final step is to substitute these values in the formula, simplifying it, and at the last step equate both sides and find the solution, that is the values of x, y and z. So these are the 6 steps we have to follow for matrix method. So let's take one example, solve these equations using matrix method. So first we will write down the given equations in the standard form of simultaneous equation, which is ax, that is term of x plus by term of y second plus cz term of z, and on right hand side constant, that is d. So let's check the first equation, x plus 3y plus 2z is equals to 6 is in the standard form or not. So it is in the standard form. Look here, term of x, term of y, term of z, and constant is on right hand side. So write it as it is. Equation 2, it is also in the standard form, term of x, then term of y, term of z, and constant to the right hand side. Now equation 3, check, it is also in the standard form, term of x, then term of y, then term of z, and constant is on right hand side. So what is the step 1 to solve simultaneous equation using matrix method? Is to write the formula for matrix method, which is x is equals to A inverse into B. So where matrix x is known as a matrix of unknowns. So the unknowns are x, y, z. whose values we are supposed to find at the end of this example. A is known as a matrix of coefficients, where in row 1 we are going to write down the coefficients of x, y, z from equation 1. So which are they? So here coefficient of x is not given, that means it is considered as a 1. So coefficient of x 1, y 3 and z 2. In row 2 we will write the coefficients of x, y, z but of equation 2. They are 3, minus 2, 5. And in row 3 we will write down the coefficients of x, y, z of equation 3, which are 2, minus 3 and 6. Do not forget to take the sign of coefficient. So 2, minus 3, 6 are the elements of row 3. And finally B is the matrix of constant on the right hand side, which are 6, 5, 7. Okay, now step 2 is to find determinant of matrix A. How to find determinant of any given matrix? By replacing square brackets with two vertical lines and elements as it is. Now this is the determinant of order 3 by 3 and we know that how to expand it. So plus first element 1, this is in first row first column, delete it and take the cross multiplication with middle sign of remaining elements. So minus 2 into 6, minus 12, middle sign minus, 5 into minus 3, minus 15, sign minus, and then second element is 3. Now this 3 is in first row second column, delete it, take the cross multiplication, 3 into 6, 18, middle sign minus, 5 into 2, 10. Now sign for the last one is plus and third element is 2. Now this 2 is in first row third column, delete it, take the cross multiplication, 3 into minus 3, minus 9, middle sign minus, minus 2 into 2, minus 4. So now just we have to simplify this. So determinant of A is equals to, look here, minus 12, here minus minus will become plus. So minus 12 plus 15 is 3. And when I multiply this 3 to 1, it will 3. Now next 18 minus 10, that is 8. And now multiply this 8 to minus 3. So 8 into minus 3 is minus 24. Now simplify this bracket. Minus 9, minus minus will become plus. So minus 9 plus 4 is minus 5. And minus 5 multiplied to 2 is minus 10. So therefore determinant of A is equals to 3 minus 24 is minus 21, minus 21 minus 10 is minus 31, which is a non-zero number. So determinant of A is minus 31 and it is a non-zero number. So inverse of the matrix exists. So next step is to find cofactor matrix of A. So cofactor matrix of A is divided into two parts. First part is to write down the sign of each cofactor. So let's write down the signs. Plus, alternate the signs only, minus, plus, next sign is minus, plus, minus, plus, minus, plus. And then second part is to find the minor of each element. Now let's see how to find the minor of each element. So first element is 1 and minor of 1 is obtained by deleting the row and column in which that element presents. So here it is present in first row first column, delete it and write down the remaining elements. So minus 2 5, minus 3 6. Now minor of 3 is obtained by deleting first row second column, which is 3 5 2 6. Next minor of 2 is obtained by deleting first row third column, which is 3 minus 2 2 minus 3. Now next minor of 3 is obtained by deleting second row first column, which is 3 2 minus 3 6. Minor of minus 2 is obtained by deleting second row second column, which is 1 2 2 6, and minor of 5 is obtained by deleting second row third column, which is 1 3 2 minus 3. Come to the last row. So minor of 2 is obtained by deleting third row first column, which is 3 2 minus 2 5. Minor of minus 3 is 1 2 3 5. Minor of 6 is 1 3 3 minus 2. In previous video lectures we have seen how to find A inverse of the given matrix. So please follow the description for the link. Okay, let us simplify this. So cofactor matrix of A is equals to plus, now expand this 2 by 2 order determinant by taking cross multiplication. So minus 2 into 6 minus 12, middle sign minus, 5 into minus 3 minus 15. Next is minus, cross multiplication again, 3 into 6 18, middle sign minus, 5 into 2 10, plus 3 into minus 3 minus 9, middle sign minus, minus 2 into 2 minus 4. Second row, sign minus, 3 into 6 18, middle sign minus, 2 into minus 3 minus 6, plus 1 into 6 6, middle sign minus, 2 into 2 4, minus 1 into minus 3 minus 3, middle sign minus, 3 into 2 6. Last row, plus 3 into 5 15, middle sign minus, 2 into minus 2 minus 4, minus 1 into 5 5, middle sign minus, 2 into 3 6, and last element plus and cross multiplication, 1 into minus 2 minus 2, middle sign minus, 3 into 3 9. So now we will simplify these brackets with the signs outside. So let us simplify this cofactor matrix of A. So to look here, first element will be minus 12, minus minus will become plus. So minus 12 plus 15 is 3. Next 18 minus 10. First solve the bracket and then give the minus sign to it. So 18 minus 10 is 8, with sign minus is minus 8. Next minus 9, minus minus will become plus. So minus 9 plus 4 is minus 5. When there is a plus sign outside, write the direct answer. Okay, now 18 minus minus will become plus. So 18 plus 6 is 24, with sign minus is minus 24. So just do the calculations carefully if there is a minus sign outside. Now next, 6 minus 4 is 2. Next, minus 3 minus 6 is minus 9, and with this minus it will become plus 9. Next, 15 minus minus will become plus. So 15 plus 4 is 19. Now next, 5 minus 6 is minus 1, and with this minus it become plus 1. And last, minus 2 minus 9 is minus 11. So this is the cofactor matrix of A. Now next step is to find adjoint of matrix A. And what is the formula for finding the adjoint of matrix A? Cofactor matrix of A, which we have seen previously, and its transpose. So let's find adjoint of A. So we have to take transpose of cofactor matrix of A. So cofactor matrix of A is this one: 3 minus 8 minus 5 minus 24 2 9 19 1 minus 11. We have to take its transpose. Now how to take the transpose of any given matrix? By interchanging rows into columns. So let's change row 1 to column 1. 3 minus 8 minus 5. Now change row 2 to column 2, minus 24 to 9, and change row 3 as a column 3, 19 1 minus 11. So adjoint of the given matrix A is 3 minus 24 19 minus 8 2 1 minus 5 9 11 minus 11 sorry, is obtained by taking the transpose of cofactor matrix. Now next step is to find A inverse using the formula 1 upon determinant of A into adjoint of A. So let's substitute the values. A inverse is equals to 1 upon determinant of A is minus 31 into adjoint of A is here 3 minus 24 19 minus 8 2 1 minus 5 9 minus 11. And now the final and important step, to put these values in the formula of matrix method, simplify it, and at the last step equate both sides to find the solution. So what is the formula? X is equals to A inverse into B. So let's substitute the value of each matrix. So X is X, Y, Z is equals to A inverse. What is the A inverse? Here it is 1 upon minus 31, 3 minus 24 19 minus 8 2 1 minus 5 9 minus 11, and into matrix B is the constant matrix, which are 6 5 7. So now simplify this. So X Y Z will be as it is equals to 1 upon minus 31 will also be there, and now we have to solve the multiplication of these two matrices. So for the multiplication of two matrices, we are going to use row by column method. That means we have to multiply rows of first matrix to each column of second matrix. So here we will multiply first row of first matrix to first column of second matrix. Now how to multiply row and column? By multiplying corresponding elements of row and column in the form of addition. So first element is multiplied to first element of column. So 3 into 6 18 in the form of addition. So plus. Now second element is minus 24 into 5, which is minus 120, plus third element 19 into 7, which is 133. Now there is no column for multiplication, so we will come to this second row and we will multiply it to first column again by taking corresponding multiplication of elements. So minus 8 into 6 minus 48 plus 2 into 5 10 plus 1 into 7, that is 7. Now lastly third row is multiplied to first column, again corresponding multiplication of elements. So first element minus 5 is multiplied to first element 6, so minus 5 into 6 minus 30, plus second element 9 into 5 45, plus third element minus 11 into 7 minus 77. So let us simplify this. So therefore x y z is equals to 1 upon minus 31. Now let's calculate these simple additions. So 18 plus minus 120 plus 133 is nothing but 31. You can use calculator for these calculations. Minus 48 plus 10 is minus 38 plus 7 is minus 31, and last minus 30 plus 45 is 15, plus minus 77 is minus 62. Now here we have to multiply this 1 upon minus 31 to each element of this matrix. So 1 upon minus 31 into 31, 1 upon minus 31 into minus 31, 1 upon minus 31 into minus 62. Now we can multiply and divide So here in the first element 31 get cancelled, so the remaining term is minus 1. Here also minus 31 get cancelled, so it is 1. Here minus 31 minus 62 is 2. So we are getting the final step. What it is? To use the condition of equality of two matrices. So two matrices are equal if their corresponding elements are equal. So what we are get? X is equals to minus 1, y is equals to 1, and z is equals to 2. So this is the required solution of the given simultaneous equations using matrix method. I hope students you understood this method very clearly. This is very important method. So thank you for watching this video. If you liked it, please subscribe to my channel Maths Academy by Sudhir.